Sometimes I find really odd stuff at the scrapyard. And today we're going to look at vintage SCSI drives. Specifically, this 1 gigabyte, 3.2 kilograms SCSI hard drive. Hello everyone and welcome back. Today we're going to look at the SCSI hard drive. I will be very honest, I've never used a SCSI device in the past. I always used IDE devices because they sounded a lot easier to set up. You just had this one jumper at the back of the device that selected between master and slave drive, and that's it. Now with SCSI devices, this is a little bit different. There are terminators that you have to have on the bus. There are different SCSI IDs you have to set on your devices. And this is just what I remember from the past. And obviously I did refresh my mind. I did dig through some documentation about this drive and another drive that we will look at in a moment. I picked this device up because it's just huge. Doesn't even fit in the camera frame right now. It's heavy. It's 3.2 kilograms. And I believe it has 7 or 8 platters inside. And it was connected in an array of hard drives. So there were like 6 of these drives in one assembly. And I couldn't take everything because, well, they take a lot of space. They're heavy. And not all of them looked good. This one was one of the drives that was in the center, so it wasn't scratched. That's why I took this one. Let me add this other device that I also mentioned. This one here is a DVD drive. This is a normal 5¼ inch drive, and you see it's double the height of the CD-ROM drive. Yeah, and I already dug through documentation trying to figure out what is going on with the termination, what's going on with the SCSI ID. And for those of you that have used SCSI devices in the past, that may be not interesting, but I'm using this for the first time. And I'm sure there are people out there who never used SCSI in their life. I think this is very interesting. And I also want to know if this drive works because, well, I haven't powered it on. I don't even know if I will get it recognized on one of my adapters, which I will also show in a moment, but it's a full-in-box Adaptec AHA-1542CF adapter. One sad thing about this device is that I'm missing the resistor packs, which have to do with the termination of this drive. And the resistor packs go in these holes, and there are 3 sets of them. So there is going 1, 2, and 3. These resistor packs you need if this device is the only device on the SCSI bus and you need to terminate it. Now in my case, I don't have the resistor packs. That means I cannot run this drive by itself. That is why I'm using the CD-ROM drive today as a terminator. It has a built-in termination as far as I understand. I really don't know if all of this will work, but well, I want to know if I can get this drive to work. So yeah, I'm missing the resistor packs. That's a little bit unfortunate, but yeah, I could probably have taken them from one of the other drives in that big array that I found at the scrapyard, but I only found out after I read through the manual that, well, these resistor packs are kind of important if you only have this drive on the SCSI bus. The SCSI bus allows you to connect up to 8 devices on one cable. And one of these devices is the host controller, so the SCSI controller. And then you can add another 7 devices if you want to. Each device needs to have a unique ID. So 3 of these pin header pairs are used to determine what device ID this drive has. Okay, I changed the setup now. We're looking at the back of the drive now. You can see the power connector. This is the 50-pin connector for the data cable. And here's the pin header for configuring our drive. And for this, you really need the manual. This is device ID number 1. No other device on the SCSI bus can share the same device ID. This must be unique, and this hard drive is taking ID number 1. And finally, this last pair is there to have a delayed start of the drive. So if you have multiple drives in your system and you don't want to power them all on at the same time, because one of these drives, when you power it on, can draw up to 4.5 amps from the 12-volt line. This is crazy. And imagine you have 6 of those drives at the same time powering up. Well, you're taking 300 watts just to power on the drives. But if you close this jumper, the drive will wait 16 seconds multiplied by the device ID before it powers on. So if it's device ID 0, it will power on immediately. If it's device ID 1, as it is this, it will wait 16 seconds before it spins up the motor. And if it's device ID 2, it will wait 32 seconds, and so on. Okay, but now I think we all want to hear how this drive sounds when we power it on. Wow, I think this drive may actually work. Okay, wow, this drive may actually work. I'm really curious if it's going to be detected on my SCSI controller later on. But now let's have a look at the CD-ROM drive, because I do need a terminator. As I said before, I don't have the terminator resistors, so I need to misuse this CD-ROM drive. I don't know if this will work, but this drive has a built-in terminator, so yeah, hopefully this will work. And here we also find one of these pin connectors, and some of them are very familiar. For instance, here is the SCSI ID. So this is ID number 3. This is the default configuration of this drive. I found this also in the manual. And the 5th pin pair here is the important one. This allows us to enable the termination circuit. Now, since I don't have it on my hard drive, I hope that this one will work. Also, this drive should be the last drive on our SCSI cable. But yeah, so this is the SCSI drive, how I set it up right now. It's a Plextor PX-12TSi. Okay, now let's have a look at our SCSI adapter. It is very rare to find in-box items, but, well, I got the Adaptec box, and here is the SCSI adapter. Yeah, we have the device itself. This one was used. You see, unfortunately, the scratches on the BIOS chips. So yeah, this was definitely in use, and it was outside. I already played around with this a little bit. I hooked up a floppy drive, so you can hook up a floppy drive here. And here's our 50-pin SCSI port. You also have an external port here, which we are not going to use. And what's really cool, all the manuals are here. This manual is for the adapter itself. In here are all the configurations and a lot of knowledge about SCSI devices. So yeah, that's definitely something that I should read probably. But that's not all. So there's more stuff in here. These ones here are the floppy disks. So what do we have? We have 4 floppy disks in here. We have OS2 and NetWare. This is not what we need. This is disk 2, disk 3. I guess this is, yeah, disk 1. Okay, so we have all 3 floppy disks. It's the Adaptec EZ-SCSI. I actually could make backups of these disks and they are working. So I'm really happy about that. Here are utilities on it, like formatting the drive and doing some other things. But that's still not all. We get another user guide for NetWare OS2, Windows NT, and Unix. So yeah, that's... I don't know what is in here, but it looks like you can learn everything that you need to about SCSI devices. But that's not all. There's another manual in here. This is the manual for the software that comes on these disks. So this probably is also very interesting to go through. And here we have a 50-pin SCSI cable that has never been used. At least it looks like it. I think this one here goes to the controller. And then we have two connectors, which one will go to our hard drive. I think I have to plug the hard drive on this port. And here will go our CD-ROM drive. And this one will be terminated. Okay, and then we have a warranty and registration card. Everything is here. 5-year limited warranty. I think that controller is from 1992. Okay, so then we have Microsoft. I don't know if this was part of this. What is here? Installation guide. Okay, so you get a table here which allows you to change these dip switches that are on the controller where the BIOS is supposed to be located in memory. That's interesting. Here you also have which address is used for the card. Okay, that's definitely handy for this controller. Congratulations on your purchase, or find at the scrapyard. 5 1/4 diskettes are available for the asking. There are 2 ways in which to proceed. Okay, so if you don't have a 3.5-inch floppy drive, you could get replacement diskettes for your 5 1/4-inch floppy drive. That's interesting. Yeah, so that's it. Okay, I think we have everything now. The only thing I need to do is I need to put a system together, and hopefully we'll be able to access this big hard drive. That's the goal of this video. So I'm diving into this ancient 1GB SCSI hard drive for the first time, figuring out how this tech from decades ago actually works. It's like solving a puzzle, and honestly, the problem-solving mindset is what I love about fiddling with vintage hardware like this. That's why I'm excited to tell you about today's sponsor, Brilliant. Brilliant helps you to get smarter every day with thousands of interactive lessons in math, science, programming, data analysis, and AI. Brilliant's programming courses are perfect for anyone curious about software development. They teach you to think like a programmer, breaking down complex problems into manageable chunks of code. You can start coding in Python on day 1, building real programs while sharpening your problem-solving skills. It's hands-on, engaging, and way more effective than just watching lectures. To try Brilliant for free for 30 days, head over to brilliant.org/bitsonbolts or scan the QR code on screen. You'll also get 20% off an annual premium subscription if you're using my link, which you can find in the video description and in the first pinned comment. So, start learning with Brilliant today. Trust me, your brain will thank you. The system I will set up right now is built around the M396F mainboard. It has a Texas Instruments 486 SLC. This board is great because it doesn't have any onboard IDE controllers or floppy controllers, so we will not run into any conflicts. I tried the controller on a Pentium 2 board with LX chipset, and the controller simply didn't show up, even though the board has ISA slots and it should be working. But anyway, so we'll use this board, but I have more interesting stuff that I found. As graphics card, we use this Orchid Technology ProDesigner 2S. It is a Tseng ET4000AX chipset. It has 1 MB of video memory, and you may know this logo from something else. This is the company that released the first ever Voodoo graphics accelerator, the Orchid Righteous 3D. The hard drive powered down. That's interesting. The hard drive is not on. Let me quickly set up the BIOS and then we'll see what happens. So I think in the BIOS we have to set up the floppy drive, otherwise it would not show up. We don't have any onboard controllers, so we don't have to worry about these. And I think this is it. So let's see if the controller shows up. Oh. Okay, something is happening. Host adapter shadow. Yeah, okay, so this is, I think this is this board that doesn't allow shadowing of BIOSes in the ROM except for the VGA and the system BIOS. That's not good. Let me double check what's going on here. Yeah, okay, that is my bad. I missed to enable the floppy controller on the SCSI controller card. That was probably from a previous test when I tried to figure out if this controller card actually works. But we only have to flip this dip switch, and now we can try again. Oh, floppy disk is accessed. And we get, oh, there we go. Unfortunately, the hard drive is powered down, so I'm not sure if we have to issue a command to power on the hard drive. So C is definitely not available. Let me figure out if we can add one of these utility disks to access the controller. Okay, what do we have on this drive? I think I have to install this first. That would be a bit of a shame because I do not have a drive and I wanted to try it without any help of an IDE device. Let's try DOS inst. Yeah, it doesn't find drive C. That's why we get invalid drive specification. And I think this is causing already an issue. So these are the floppy disks that came with the controller. Yeah, so yeah, this is a problem. Difficult. Okay, I prepared a bootable floppy disk. For now, I just want to see if I can get somehow into a controller setup and see if we can configure the drive. That's all I want for now. And we're booting from drive A. And the SCSI software is loading. Hey, and we get drives. And we see SCSI ID 1 is reporting 94601. I think this is the drive, so this is there. And we also have the Plextor CD-ROM PX-12TSi. Wow. Okay, I am super surprised that my floppy disk actually worked. Okay, so I don't think we have a drive C. Okay, but I should have a lot of other software here. Actually, it's in the SCSI folder. SCSI setup. Oh, perfect. SCSI disk setup program. There we go. So AF disk. This is probably what we need. The motor of the hard drive still hasn't spun up. Okay, so here is our drive. Check condition, not ready. Not ready error. Okay, yeah, because it didn't spin up. That's because I added this one jumper to wait until it receives the start command from the SCSI controller. But maybe this is just not something that's supported here. Okay, let me remove the jumper and then we'll try this again. Now the drive should power up as soon as we power on the system. And yes. The drive definitely spins up right now. And it clicked. Okay, hopefully we will not get an error message now. Oh! Nice! Logical drive info, okay. Insert, create, delete. Okay, so looks like there's absolutely no partition in there. That's like F-disk basically. So let's press insert. Start cylinder 0. Yes, I want a full partition. The BIOS of this motherboard only supports up to 500 megabytes, and that's another test I wanted to try. Because the SCSI controller has its own BIOS, I should be able to access a drive that is much larger than this motherboard supports. So let's see. And create partition. Yes. Please wait. Okay, that's it. That's it. I think we can't do anything else here. Please reboot the system to save the changes made. Okay. I'm curious now. That huge hard drive with 1 gigabyte of space survived the ordeals of the scrapyard. So we're still booting from the floppy drive. It has the SCSI software installed and it pops up here. But now, let's see if we have access to drive C. No, still not. Luckily, I put F-disk on my drive. Let's see if we can use it. No fixed disks present. Oh, that's not good. I thought we created a partition. Let's see, there was a formatting, I think. SCSI FMT, SCSI FMT. Low-level formatter. I don't want to low-level format, to be honest. I just want to access my drive. Let's go to AF disk again. Okay. Shows up here. Interesting. But I cannot access it from DOS. I do believe that our SCSI setup is working correctly because we saw all the drives showing up, and I could even format the drive using the utilities that are supplied by Adaptec, and they're showing up here. So yeah, that's very promising, but still there is an issue with accessing the disk. So I'll try to just create a RAM drive right now, so I have a drive C, and then I will try the setup utility one more time. So we do have the RAM drive.sys in here, and we should be able to create a RAM drive with this. So we only have to add one line into the config sys, and hopefully that will work. By the way, if you want to play around with the RAM drive, I already have another video on my channel where I explain this more in detail. To use the RAM drive capabilities, I had to copy a file from an MS-DOS installation, the ramdrive.sys file. Unfortunately, or fortunately in this case, I had to swap the SCSI controller for an IDE controller to access my DOS installation that was on a compact flash card. Once I was done, I had to swap the IDE controller for the SCSI controller again. But what I didn't notice is that I used a different ISA slot. And this is when everything started to change. Okay. Troubleshooting 35-year-old computer systems. Okay, now we have a boot disk that should set up a RAM drive. Hey, wait a second, what is this? That's new. I didn't see this ever before. What happened? Yes, it should be 330. I only switched ISA slots now. I switched things around. I moved my SCSI adapter now one slot away from where it was before, and now I have access to this. Adapter IRQ channel. My goodness, really? It was an issue with an ISA slot? SCSI drive configuration. Advanced configuration options. Okay, send start command. Oh my goodness, I have the start command here now. Options listed below are no effect if BIOS is disabled. Oh. Wow, that's interesting. So this is the start command for my drive. Now things get suddenly so much easier, and I know already what all these things mean. Enable disconnection, enable fast SCSI, these ones I don't know. Enable sync negotiation. Let's see, advanced configuration options. Floppy controller. Host adapter BIOS configuration enabled. Okay, so this is okay. I'll leave this all by default. Save changes, yes. So the only thing that we changed right now is we are sending the start command. And this is something that I want to figure out if this works. This might have been the reason why we couldn't access the drive, because the BIOS was never loaded. I didn't know this is a big deal, but apparently it is. SCSI disk utilities. That's scanning the entire bus, and we have the hard drive on channel 1 or SCSI ID 1, and we have the Plextor on ID 3, and our adapter is on ID 7. Okay, great. Can we do something with these? Can we format disk, verify disk media? What happens if I click format? This drive is about to be low-level format. No, I don't want this. But can we verify the disk media? This drive will be scanned for media defects. I've never heard the drive actually do something. Well, I can hear something, but it's very silent. And that might take a while. Okay, we are almost done with verifying the disk. I'm curious if we get a report at the end of this. Disk verification complete in red. I think this disk is actually in working condition. Host adapter diagnostics. What can we do here? So run diagnostics. Yes. Okay, let's see if we get a successful test loop. Okay, and we have one successful test loop. Now we need to restart the system, and this is anyway interesting because I want to see if we get the BIOS message again. This is something that I wasn't aware of, that an ISA slot can cause so many issues. It probably depends on the implementation on the motherboard, but it was not on my list to just move the ISA slots and suddenly the BIOS can be installed in the high memory area. And by the way, let me know if you have used SCSI devices back then and if you have used something like this, because for me this is all new territory. So yeah, it's pretty cool that, you know, things start working, and we already verified the disk, we already formatted the disk, created a DOS partition, but we still can't access it. Maybe now comes the big break and we will get a drive on the DOS that we can install MS-DOS to, and that would be really cool. Okay, so the jumper is back. Now the drive should power on only after we see the BIOS message of our SCSI controller. Okay, the drive is silent. And... oh! It did. It waits for spin up. Nice. Yes. Yes. We are getting there. Oh, well, now we'll create the RAM drive, but that's okay. So we have no IDE drive in the system at all. And here's our RAM drive. Oh, it's creating it on virtual drive C. So wait a second, virtual drive D. Wait a second. We have in the center of the screen active for drives C. Do we have drive C? No. We have the SCSI drive in MS-DOS. I can't believe it. We are nearing the end of an MS-DOS format cycle, and I'm really curious if we have bad sectors. Format complete. Okay, so we call that MS-DOS. Do we get a summary? Yes, we do. I don't think there are any bad sectors on this drive. I think this drive is 100% working. I don't want to go through this right now. So yeah, our SCSI drive is fully operational. The last thing we want to do, I want to go through the setup routine that is on those floppy disks that came in the box of the Adaptec SCSI controller. So we had the DOS inst on disk number 2. Disk number 2 is in the drive, and now hopefully this installation works. Okay, let me install MS-DOS, I think, because otherwise, yeah, we'll not go anywhere. Let's hope that the MS-DOS installation is going to detect our SCSI drive. I think this is already a good sign. Yes. I think that's all good, so painless. Let this process finish and then we'll continue once MS-DOS is installed. Hi MIMSys. Loading from our DOS installation, and we're done. 1 GB of pure SCSI goodness. This is my first experience running a SCSI drive, and I have to say, except for the issues that I had now getting this controller to work, but that was most likely the fault of the motherboard, it was a very painless experience. So now let's try to install the SCSI software. DOS inst. So now hopefully everything does work as expected. Okay, so we are in the Adaptec EZ-SCSI software installation application. It's an intelligent, easy-to-use self-loading installation manager with online help at every step. Okay. The default setup and custom setup, I think the only difference is that in the default setup, the application searches for your SCSI adapter, for your hard drive, and so on. It's an automated installation, whereas custom, you can pick whatever you want. I want to go for default, so let's continue with enter. Continue with the default installation. Yes, scan my system, please. And it detected the SCSI adapter port 330. This is exactly what's configured on the adapter right now. And oh, it's detected. So continue. And our drives show up. Nice. So you have the Plextor and our 1 GB hard drive. Okay, fine. Let's install the application in this directory. And here we go. Oh. Does it want to install my CD-ROM drive for me? And it is going to install a CD-ROM driver apparently. So it adds 2 lines to our config sys. The first one is for our SCSI controller, and the second one I think is for our CD drive. Okay. Press escape to continue. Okay, we also need this in our auto exec. Okay. And EZ-SCSI has been successfully installed. What did you do? Oh, it tried to boot from drive A. Why did you do that? I removed the floppy disk from drive A. So do we have drive D? We do. Nice, it works. Now this is Windows 98. This is the only CD I found very quickly, but yeah, I should be able to install, well, Windows 95, Windows 3.11, whatever I want on this hard drive. I think this is all I wanted to show today. There were some hiccups, but I think I learned a lot. My first time trying SCSI devices. Let me know in the comments if you worked with SCSI devices in the past. Have you ever worked with one of those? I'm not sure what the regular IDE hard drive size was at that time, but I think in 1994 we already scratched at 1 GB. But this drive was available a few years earlier, definitely. There were just other revisions, but looks like Seagate manufactured these drives for a few years. So I think this is a longer video today, but I hope you enjoyed this excursion trying SCSI devices for the first time, for me at least. And the hard drive is in proper working condition. And the controller as well. So I have a 386/486 system right now that can run a 1 GB hard drive. This is pretty cool. Anyway, thank you for your time. Thanks for watching. Thank you to all my Patreons who are supporting my work, and I hope you enjoyed and learned something today. Take care and bye-bye.